Time is defined as the indefinite continued progress of existence and events in the past, present, and future. Let's try to visualize this. As I am speaking, time, which is measured in seconds, is passing. This is a present event as it is happening now. We have even bigger metrics for time measurement, such as minutes, hours, and days. If we talk about today, you probably spend a considerable time sleeping and doing work. But let's be honest, you probably spend some time on the internet. Days turns to week to months to year, and year to century. If we look at the 21st century, most recent innovations such as Wikipedia, YouTube, iPhone, Star Wars, and SpaceX are relatively young in terms of time perspective. This century was marked by 9/11 attacks on United States, followed by Afghanistan and Iraq war, then Syrian civil war, more recently the COVID-19 situation. But this is just one century. In the last century, humanity endured the horrors of World War I and World War II, one of the most destructive conflicts in human history. After that, we had the era of Cold War, where the danger of nuclear apocalypse and mutual destruction were ever present. We also landed on the moon in the same century, and internet came into being with Facebook and Twitter spawning at the end of the century. However, this is just only 2 centuries. The concept of time is much older, spanning millennia. Have you ever wondered how time is measured or how to determine world's time zone? The scientists take advantage of physical clocks to determine time. A physical clock is dependent on a repeating physical process calculated by a specific method. One example of this is the Earth's rotation around the Sun, calculated in solar days. Physical clocks mostly work in cyclical manner. The determination of world's time zone require one or more physical clocks. Every concrete time is a measurement of some physical clock. For instance, a winded watch measures time now by measuring the rate at which a coiled wound spring unwinds. A physical clock always has its limitations. Some are run by batteries, some can be wound up, some by sand, some by sun, and some by water. Across the world, according to International System of Units, time is measured in seconds. But what really is a second? And how is it calculated? 1 second is the time that elapses during 9,192,631,770 cycles of radiations produced by the transition between two levels of cesium-133 atom. This is measured by an atomic clock, also known as radio clock. Atomic clocks are so accurate that they are expected to make 1 second error in about, can you guess? If you guessed 100 or 200,000 years, that is incorrect. The clock is known to make 1 second error in about 10 million years. Because of their accuracy, instead of physical clocks, atomic clocks are used in determination of time or second. Why time is so important in scientific experiments? This is so we can record observations and perform experiments in fixed intervals that remain constant for accurate result. Physical clocks based on physical processes are not accurate enough as they are subject to variations. Solar clocks based on sunrise and sunset are inaccurate as the Earth does not revolve around the Sun in exactly 365 days. This is why we need to add 1 day for every leap year. Moreover, the duration of daytime and nighttime also varies with summer and winter season. A more accurate determination of time interval is made by atomic clocks. These clocks measure time based on fixed and regular vibrations of atoms or molecules. They are so accurate that they make 1 second error in 10 million years, so it's reasonably assumed that the interval measured by atomic clocks is constant. In our syllabus, Instruments to measure time include stopwatch and clock. In most questions, you will be asked to determine the time interval, which is the difference between the starting and ending time. So let's assume a race starts at 12 pm and finished at 1 pm. The race duration in this case is final time minus initial time. These are marked by the red lines. The race ended at 1 pm. In 24-hour format, this is 1300 hours. The race started on 12 pm. In 24-hour format, this is 1200 hours. Race duration is the difference between the two values, so 13 minus 12 equals to 1 hour duration. The next instrument is the stopwatch. In most questions, you will be asked to determine the time difference between the starting and ending time. So let's assume a race starts at 0-second mark on stopwatch and ends on 90-second mark. The race duration in this case is final time minus initial time. The race ended at 90-second mark and started on 0-second mark. Race duration is the difference between the two values. So 90 minus 0 equals 90-second duration. Next type of question involves the use of ratio method. Let's assume that the mighty legendary Pokemon Arceus can summon one Pokemon in 2 seconds. Assuming the same level of power, how long will it take Arceus to summon 3 Pokemons? We can solve this through ratio method. If one Pokemon in 2 seconds, then 3 Pokemons in unknown or X seconds. By cross multiplying, the unknown seconds is equal to 3 multiplied by 2 equals 6 seconds. This is just a brief mention of ratio method. We have already discussed this in previous sessions. Moreover, you should be familiar with it through your math studies. Consider an object of small mass suspended by means of a wire, thread, or string. This setup is called a simple pendulum. This can be used in time determination. In a simple pendulum, it is assumed that the string is massless and the object tied to the end of the spring is point mass. Both of these assumptions are inaccurate. The string cannot be massless in reality as it is made up of number of atoms or molecules. Moreover, the entire mass is just not concentrated at one point in the object. However, if we make a sufficiently thin string and a sufficiently small object heavier than the string, such as a small stone or a metallic ball, we are close to having a simple pendulum. Therefore, we assume our setup to be a simple pendulum anyways. The object attached to one end of the string is known as bob of the pendulum. Initially, the pendulum is at rest. The position of the bob is what we call rest position or mean position. Now, what will happen if I give this bob a little push in either direction? You can see the bob starts moving back and forth. This back and forth motion is repetitive in nature and hence is known as oscillatory motion or cyclical motion. So when does it complete one cycle? We say the bob has covered one cycle or one oscillation when it moves from the mean to one extreme, then to the other extreme, and back to the mean. Let's repeat. From the mean to one extreme, then other extreme, and back to mean is known as oscillation. Now the motion of this pendulum is affected by the air and it eventually comes to a halt after some time. However, under ideal conditions, the motion will simply repeat itself forever in equal intervals of time. Such a motion is called periodic motion and time for this motion is called time period. The time for each periodic motion remains the same, meaning if it took 3 seconds to complete the first oscillation, then it will take 3 seconds to complete the second oscillation, and so forth. In an ideal condition, the small displacement from mean position to one extreme is equal to the small displacement from mean of the other extreme. It is this property that makes pendulum very good timekeepers. This property is why pendulum clocks were used from 17th to 19th century to measure time before being replaced by electric clocks. Time for one oscillation or cycle is known as time period. One cycle is the distance the bob moves from its rest or mean position to one extreme, then to other extreme, and eventually back to its rest position. To repeat, the distance from rest or mean position to one extreme, then to other extreme, and eventually back to its rest position. Usually, stopwatch is started by press of a button when the pendulum is released, and stopped by press of a button when the pendulum completes one cycle. This pressing of button on stopwatch adds additional time to the observation of time period, also known as human reaction time. Typical human reaction time is in between 0.3 to 0.5 seconds, which is admittedly small. However, in a reading of 1 second time period, this adds up to 1.5 seconds. 1 second for the time period and another 0.5 seconds for the human reaction time. This represents 33% error, which is too large for a scientific observation. Now, human reaction time cannot be eliminated altogether if the stopwatch is operated by a human being. However, we can reduce the reaction time error by measuring the average time period for multiple oscillations. This means that instead of determining the time for one oscillation, we determine the time taken by the pendulum for 20 oscillations. Once we have the time, we can divide it by the number of oscillations, in this case 20, to find the time period for one oscillation. Let's assume that the time period for 20 oscillations was 5 seconds. What is the time period for one oscillation? We divide the time for total oscillations by the number of oscillations. In this case, 5 divided by 20. So the time period for one oscillation is 0.25 seconds. How does averaging help in reducing the human reaction error? It divides it by a greater number, spreading its value over each observation. So by taking average time period, we reduce the instance of error occurring. In our syllabus, the time questions you will encounter falls broadly into the following types. First, time difference questions where you subtract the final time value from initial time value to determine duration. Second, the question requires you to use ratio method to determine unknown quantity through use of known or predetermined relationship. Thirdly, questions regarding pendulum and the procedure to reduce the impact of human reaction time on time period for one oscillation.